Okay, so today we'll solve mathematics get 2023 question. This is a question from functional analysis. This is a question number 32. It is saying that let L2 of minus 1 comma 1. So this is basically all square integrable function where the functions are Lebesgue measurable. Right, so this f is a function of minus 1 to 1 to r. F is Lebesgue measurable and the function should be square integral in minus 1 to 1. With the norm, because this is finite, then you will take this quantity to the power half, then this will become a norm. Now let's define the linear functional on this space. So this is basically the Hilbert space. It will be complete norm linear space. So then define the linear functional on this Monarch space or Hilbert space by f of some f. It will be given by my integral with respect to the x square from minus 1 to 1 and for all f in L2 of minus 1. Then you have to find the norm of this functional. Means if this is denote the norm of the linear functional, then you have to find the f 5 times norm f square. What will be the value of this? Okay. So this is the NPTEL reference. So you can look at it in order to solve this. Okay, we will use ridge representation theory basically to solve this problem. So what is this saying? Ridge representation theorem. So this is basically characterize all bounded linear functional on a Hilbert space, right? And so basically L2 of over some set, you can take any compact metric space or locally compact. So L2 of that will be a Hilbert space. So basically it is saying that let T be a bounded linear functional on, here I am stating only for L2 of over some set X because I only need this one, but this is true for any in Hilbert space, or more generally this theorem can be true for LP spaces, not necessarily Hilbert spaces. Then there exists a unique G in L2 of X such that T of F is given by integral of F Fx Gx bar, and this is the measure in the X space X. So this is, we will take the measure space of X. There is a measure for all f in L2 of X, and moreover the norm of this functional will be equal to the norm of this function G. So in the left hand side, this is basically the operator norm, functional norm. This is the operator or functional norm, and the right hand side, this is basically norm of functional norm. So this is L2 of this X, right? Okay, so ridge representation is saying that take any bounded linear functional, it will be given by this integral form, and the operator norm of this functional will be same as the norm of this function G, right? And so this is the L2. I have stated it for only L2 of X, but more generally any Hilbert space there is a notion of inner product. So there you can say that if there is any bounded linear functional, then there is a unique function in again that Hilbert space. It will be given by this, like this inner product T of f, it will be some given by f with some inner product g, and the norm of this T will be the norm of g, right? So it is for Hilbert space. And more generally for LP spaces, this type of theorem is also true, but there then the G will be belongs in some LP dash space, where P dash is the conjugate exponent 1 by P plus 1 by Q. This type of is satisfies. Means if you take F from LP, then G will belongs to in LQ space, and it will be unique, and it will be given by this type of integral formula, and the norm will be again this. So this is more general version for LP. I have only stated for L2 only, because I in that solving this I only need for L2. Okay. And what is this? Let me write also the what is this functional norm? Not recall, so let me. What is this norm of this functional? So this is given by the supremum of all f which is less than equals to 1 times mod of Tf. So this is the functional norm of T, and G is the norm in L2, right? Now here we have the functional is given by this. So this is a functional in L2 of minus 1 comma 1. Here we have the space is L2 over the set minus 1 comma 1. So this is again a Hilbert space, and so this is Hilbert space, and again f is in L2 of minus 1 comma 1. Then the norm of f, how it is L2 norm, it is defined like this: integral from minus 1 to 1 mod of fx square dx. This is the Lebesgue measure to the power half. So this is the norm here. And how the linear functional is defined? So capital F is a linear functional from L2 of minus 1 comma 1 with respect to this norm to R. This is because this is a functional. And how it is given? F, it will take any function, it will be given by this integral from minus 1 to 1 fx and x squared. So this is the given for that. Here it is saying that the functional is given by this. Right. So this is a functional on L2 of A. So by ridge representation we know that because here f is a functional, it will be given like this, and it will be given by the integral of some over some function g. So here g is this x square. Then what will be the norm of f? So norm of will be the norm of g. So therefore by ridge representation theorem, norm of f will be norm of this x square, right, in L2 minus 1 comma 1, right. So therefore we have to only find the norm of x square in L2 minus 1 comma 1. So now norm of, what is the norm of x square here? L2 minus 1 comma 1. So this is basically integration from minus 1 to 1 x square and mod this is x square dx to the power half. So this is minus 1 to 1 x to the power 4 dx to the power half. So the integration will be x to the power 5 by 5, integral from minus 1 to 1 to the power half. So if you put the values 1, it will be 2 by 5 and square root, right? So norm of x square we get square root of 2 by 5. So therefore norm of f, which is norm of x square, so functional norm here, this is the norm of x square, which is square root of 2 by 5. So this is the functional norm. Now let's see what we have to find. We have to find the value of 5 times norm of f square. So then five times norm f square, 5 into 2 by 5, so it's 2. So the answer is 2. Then 5 times norm f square, it is the basically 2. Okay.